Welcome to Two Projects. In this video, we are going to explain the project, a graph-based framework for traffic forecasting and congestion detection using online images from multiple cameras. Before diving into the execution, let me give you an overview of the project. So nowadays, the efficient movement of people and goods is very important for economic vitality and environmental sustainability. But traffic congestion poses significant challenges to the smooth functioning of transportation systems, leading to increased travel times, fuel consumption, emissions, and stress for commuters. And traffic congestion is a multifaceted problem influenced by various factors, including population growth, urbanization, inadequate infrastructure, inefficient transportation policies, and unpredictable traffic patterns. As cities continue to expand and populations grow, addressing traffic congestion becomes increasingly urgent to ensure the continued mobility and well being of residents. But traditional methods of traffic management, such as static traffic signals and manual enforcement, are often ineffective in addressing the dynamic nature of congestion and fail to provide real time insights into traffic conditions. So, the project uses images captured by multiple cameras to monitor traffic conditions and identify congestion areas. It uses advanced image processing techniques and deep learning models to provide comprehensive insights into the congestion levels. So it categorizes traffic into three main classes: high traffic, medium traffic, and no or low traffic. Deep learning models such as YOLO, that is, you only look once, play a crucial role in analyzing the images and detecting vehicles. These models are trained to recognize patterns and objects within the images, enabling accurate identification of vehicles and assessment of traffic conditions. So, we will be building these YOLO models and other deep learning models for detecting the congestion. Now, we look at the workflow. So the dataset comprises images captured by various cameras showcasing different traffic scenarios. Before these images can be used for analysis, they undergo exploration. So the first step is reading the images. That is, images are loaded into the system for further processing. And to facilitate efficient processing, the images are converted into blob objects, which are a specific data format suitable for deep learning models. And each image is labeled to identify the objects of interest, such as vehicles, pedestrians, or background elements. And bounding boxes are drawn around these objects to indicate their locations within the image. The image data is converted into NumPy arrays, which are a popular data structure in Python for numerical computations. So, this conversion enables easy manipulation and processing of the image data. Once the dataset is prepared in this way, it undergoes various image processing techniques to enhance its usability for model training. So, annotations are added to the images to provide additional information such as object labels and bounding box coordinates. These annotations help the model learn to recognize and localize objects correctly. And the color format of the images is typically in BGR, that is blue, green, red format. But many deep learning models expect images in RGB, that is red, green, blue format. So the images are converted from BGR to RGB format to ensure compatibility within the models. And masks are created to highlight specific regions of interest within the images. After this, we will resize the images. So images may vary in size, which can affect the performance of deep learning models. So all images are resized to a standardized dimension to ensure consistency during processing. Later, data augmentation techniques are applied to increase the diversity and robustness of the dataset. So we will be training the models on original images but from different angles so that the models can generalize well to different conditions. So data augmentation techniques include randomizing images, such as flipping horizontally or vertically, adjusting brightness, or adding noise. So, this introduces variability into the dataset, making the models more resilient to different conditions. And will rotate the images at various angles to simulate different viewing perspectives. This helps the model generalize better to unseen orientations of objects. Additional transformations such as scaling, sharing, cropping are applied to the dataset to improve the model's ability to handle variations in real world scenarios. So, by undergoing dataset exploration, image processing, and data augmentation, the dataset is prepared in a format suitable for training deep learning models for congestion detection. So, these steps ensure that the models are trained on a diverse and representative dataset, leading to better performance and generalization ability. So, the project uses deep learning models such as YOLO, FastRCNN, SSD, and RetinaNet to detect and localize objects in images with high precision and efficiency. The benefits of this project include improving traffic management, enabling informed decisions, and improving road safety. Traffic management authorities can use the insights to make informed decisions, deploy resources effectively, and implement strategies to alleviate congestion. Commuters can plan their routes more efficiently and optimize travel times. Urban planners can use the findings to optimize road layouts and prioritize infrastructure investments. So, the main objective of the project is to enhance transportation system efficiency, improve traffic management strategies, and improve road safety by identifying congestion hotspots and potential bottlenecks. The project also provides actionable insights to stakeholders, enabling them to make informed decisions and take proactive measures to address traffic congestion. So, this is what happens in this project. Now, we look at the software and hardware requirements. So, hardware requirements are operating system of Windows, processor of i5 and above, RAM of 8 GB and above, and hard disk of 25 GB and above. Software requirements to execute this project are application needed is Anaconda, primary language required is Python, front-end framework needed is Flask, back-end framework needed is Jupyter Notebook, database required is SQLite 3, and front-end technologies required are HTML, CSS, JavaScript, and Bootstrap 4. Now we look at the algorithms built. So these are all the algorithms trained in this project. So we have trained them and we have compared their performance using different performance metrics like precision recall and MAP scores. And we have observed that YOLO V5X6 has outperformed all other models in all the performance metrics. So we have deployed YOLO V5X6 into the Flask web application. Now we will understand about the deployed algorithm, that is the best performing algorithm YOLO V5X6. So YOLO, that is You Only Look Once, is a computer vision object detection algorithm that quickly identifies objects in images by splitting the input image into a grid and simultaneously predicting bounding boxes and class probabilities. Unlike traditional methods, YOLO processes the image just once, making it extremely fast. It predicts multiple bounding boxes and their associated class probabilities for each grid cell and then removes redundant detections using non-maximum suppression. This results in a final list of detected objects along with their bounding boxes and probabilities. So these are different architectures in YOLO. YOLO V5X6 is a variant of the YOLO V5 object detection model designed to strike a balance between accuracy and speed. With around 2.4 million parameters, it offers good precision and recall while maintaining efficient processing speed. Its architecture is optimized to handle 1280 by 1280 input images, making it suitable for real-time object detection tasks. So YOLO V5X6 is chosen for this project due to its ability to provide accurate and fast detection, making it well suited for identifying objects. So this medium-sized architecture and optimized parameters allow for efficient processing of images while maintaining high detection accuracy, aligning perfectly with the project's objective of enhancing congestion detection capabilities in complex environments. So this is about the YOLO V5XX model. Now we will execute the project. So to execute this project, before executing this project, first we need to open the code folder which contains the project source code files. So this is the code folder and these are the contents I have in the code folder. This is sample folder in which I have images on which will make the detections. This is static folder. This folder consists of files related to CSS, JavaScript and Bootstrap. This is templates folder. This folder contains all the HTML pages used in the project. It typically includes files like index.html, about.html, etc., which represent different pages of the website. These are YOLO V5, YOLO V6, YOLO V7, and YOLO V8 folders in which I have respective dataset for that particular model. So I'm opening YOLO V5 folder. We can say I have train and validation folders. In train folder, I have two subfolders, images and labels. In images folder, I have these traffic images in which I have three classes of images: high traffic, medium traffic, and low or no traffic. And in labels folder, I have label or annotation files. So each label file corresponds to an image file in the images folder, providing details about the object's locations and classes within the image. So this annotation file corresponds to this image. In the same way, this annotation file corresponds to this image. Similarly, each annotation file corresponds to an image in the images folder. So these label files often follow the YOLO format where each line, so this is the line, represents a detected object. So each line specifies the object's class index. The first column is the class index, followed by its bounding box coordinates normalized to the image dimensions. So these are the bounding box coordinates. This is the X limit, this is Y limit, this is width, and this is the height. So we can see in this image, there is one object detected. So in the second image, we can see there are two objects detected. So these are the class index. The first column is the class index, followed by the bounding box coordinates. These are the bounding box coordinates of the objects detected. So in the same way, I have class index followed by the bounding box coordinates in the other label files also, which correspond to an image in the images folder. So we will be training the YOLO models, YOLO V5 model on these images and the label files. I have validation folder also here, and in validation folder also I have images and label folders. So on these images and label files, we will be evaluating the model performance. And I have YOLO V5, YOLO V6, YOLO V7, and YOLO V8 folders separately. But each folder contains the same images, but they are annotated differently because each YOLO version requires its own specific type of image annotations for training and testing the models effectively. And having separate folders helps keep the dataset organized and ensures that each YOLO version receives the correct annotations it needs to function properly. That is the reason we have four different folders for YOLO V5, YOLO V6, YOLO V7, and YOLO V8 here. Next, coming to app.py file. So this .py file contains the information related to front-end logic. It includes code-written Python that handles server-side operations such as processing user requests, interacting with the database, and generating dynamic content to be rendered in the HTML templates. And these are model files which contain algorithm information. These files will be loaded into the project code during runtime to utilize the trained models. This is Notebook Jupyter source file which contains a combination of code, graphs, and outputs all in one place. So Jupyter Notebook allows users to execute code in individual cells making it a popular choice for data science. And this is signup.db file. This file is the database file used to store user information. So it stores information like sign up details of the users. This is about the code folder. Now copy the path of the code folder from the address bar of the file explorer. So this is the path, I'm copying it. Open Anaconda prompt. Use the command cd followed by a space and paste the copied path and hit the enter button. So this command is used to change the current directory to the code folder's path. Now compile the app.py file using the command python space app.py. I'm typing python space app.py and hit the enter button. So this command will execute the script, Python script, and perform a runtime check for any syntax errors or logical issues. And after running the app.py file, the Flask framework will host the application locally at the default address localhost and port unless configured differently. Now copy the local link provided by the framework. I'm copying it and paste it into any web browser. I usually prefer Chrome. After pasting it, hit the enter button. So the home page of the project has been displayed in the browser. This is the front end built using Flask framework. So here we can see a sign up link, click on it. If we are new users, we have to register ourselves first, fill in all these details and click on register button to sign up. And if we already have an account, we can directly log in by clicking on this link. As I'm already a member, I'm clicking on this link. Here we have to give our credentials, username and password. I'm giving mine and click on login button. So it has redirected us to the detection page. So now we have to upload any traffic image here and the application will detect the congestion from the image. Click on choose file button. From sample images folder, these are the test cases I have. Will select this image, click on open. The image has been loaded. Now click on upload button. So we can see the application has detected congestion from the image. It has drawn a bounding box around the detected congestion and it has classified this congestion type as high traffic. So here we can see the class label and beside the label we can see a probability score telling us the confidence level of the system in classifying this congestion type as high traffic. Click on back, click on choose file, we'll try with another image. This time we'll try uploading this image. The image has been loaded. Now click on upload button. We can see the application has detected the congestion. It has drawn a bounding box around the detected congestion and it has classified this traffic type as moderate traffic. Here we can see the class label and beside the class label we can see the probability score telling us the confidence level of the system in classifying this traffic type as moderate traffic. Click on back, click on choose file. Now we'll try with this image. Select the image, click on open. Image has been loaded. Now click on upload button. So we can see the application has detected the traffic. It has drawn a bounding box around the detected vehicles and we can see it has classified this traffic type as low or no traffic. And beside the label, we can see the probability score telling us the confidence level of the system in classifying this traffic as no or low traffic. Similarly, we can upload any image from the test cases and can get the congestion detection and the classification if it is high, moderate, or low traffic. I'll try uploading this image. We can see the application has detected high traffic and moderate traffic here. It is differentiating high traffic and moderate traffic with different colored bounding boxes. And we can see the probability scores telling us the confidence level of the system in classifying them with respective class labels. Click on back. We'll try giving some more test cases. We'll try with this image. This is the uploaded image, and here we can see the application has detected moderate traffic. Here we can see the class label and we can see the probability score. Click on back, click on choose file. We'll try with this one. We can see the application has detected moderate traffic and no traffic. We'll try with this image. We can see the application has detected high traffic, and we can see the probability score beside the class label. We can see the bounding box drawn. We'll try with this image. We can see the application has detected high traffic this side and it has detected no or low traffic this side. So in this way, we have to upload the image from the test cases and get the detections. We can see the application has detected no traffic or low traffic for this image. Click on back. We can also try uploading images from Google. We'll try that. So I'm searching for traffic images. So we'll try uploading this one, download it. Click on choose file, select the downloaded image and click on open. The image has been loaded. Now click on upload button. So we can see the application has detected the congestion. It has drawn a bounding box around the detected congestion and it has classified this traffic type as high traffic. Here we can see the class label, and beside the class label we can see the probability score telling us the confidence level, how confident the system is about classifying this traffic as high traffic. Click on back. We'll try uploading another image. We'll try with this one. Download the image. This is the image. I'm selecting it. Click on open. The image has been loaded. Now click on upload button. We can see the application has detected the traffic. It has drawn a bounding box and classified this traffic type as moderate traffic. And we can see the probability score here. Click on back. We'll try with another image. We'll try with this image. Select the downloaded image and click on open. So only JPG and JPG files are allowed. Format is not suitable. We'll try uploading another image. We'll try with this one. Download the image. Select the image, click on open. The image has been loaded. Now click on upload button. We can see the application has detected moderate traffic. It has drawn a bounding box and we can see the probability score. Click on back. We'll try with this image. Download the image. Click on choose file, select the image. This is the one. Click on open. Image has been loaded. Now click on upload button. We can see the application has detected moderate traffic from the image. So we can also upload images from Google. We'll try with this image. Select the image. So this image is not suitable. The format is not suitable. We'll try giving another image. We'll try with this one. Select the image, click on open. Image has been loaded. Now click on upload button. We can see the application has detected high traffic this side and low traffic this side. So in this way, we can also download images from Google and detect the congestion from those images. Now we look at the graphs. Click on graphs link here. Here we can view all the visualizations made. This is precision and recall graph of YOLO. This is F1 confidence curve graph. This is confusion matrix of YOLO. These diagonal boxes are the correct classifications and remaining boxes are the misclassifications. This is precision scores comparison graph, a horizontal bar graph comparing precision scores. In this graph on x-axis, I have precision scores and on y-axis, I have algorithm names. So these are all the algorithms which we have built. Similarly, this is recall scores comparison graph and this is MAP scores comparison graph. So we can see from all these performance metrics graph, YOLO V5X6 has outperformed all the other models in all the performance metrics. So this is about the graphs. Now click on sign out. So the project aimed to revolutionize traffic management by leveraging advanced image processing and deep learning techniques to provide insights into congestion levels. By accurately forecasting traffic conditions and identifying congestion, it offers a promising solution to enhance transportation system efficiency and improve urban mobility.
Thank you for watching video. For more projects, please visit our website www.trueprojects.in. For updates on latest project videos, please visit True Projects YouTube channel and subscribe.